Good morning. Today we are covering solving quadratic equations by factoring. Now throughout this chapter we're going to be learning how to solve quadratic equations in different forms. Today we are solving by factoring. And all of you guys are very good at factoring at this point. But let's review first, what is a quadratic equation? A quadratic equation has the form of y is equal to ax squared plus bx plus c. And if you notice that x squared is the largest or the biggest exponent, where a cannot be 0, because if a is 0, this will disappear and we no longer have a x squared. So in order for it to be x squared, a cannot be 0. That means on your equation we must have x squared. It's a U-shaped and we call it a parabola. And you can use factoring to solve certain quadratic equations. But throughout this class, we are going to be solving quadratic equations by factoring pretty often. Now, solutions are also called roots. On the left-hand side, let's go and write down the following. Solutions, the solutions of an equation, of a quadratic equation, are also called roots. We also call them x-intercepts. And we also call them zeros. So all four names are basically the same thing. They're called the solutions, they're called the x-intercepts. So they're called roots, they're also called x-intercepts. Before we actually do anything, we need to be able to factor this fully. First, one number divides 6, 28, and 10. 2. What do I need to multiply 2 to get 6x squared? 3x squared. What do I need to multiply 2 to get negative 28x? Negative 14x. What do I need to multiply 2 to get negative 10? Negative 5. Then from here, I'm going to go and factor this out. Double parenthesis. Factors of 3x squared are 3x and x. Factors of negative 5 are positive 1 and negative 5. If I multiply, 3x times x is 3x squared. 3x times negative 5 will give me negative 15x. Positive 1 times x will give me positive 1x. And that gives me negative 14. And positive 1 times negative 5 will give me negative 5. So this one works. Now from here, they're called the x-intercept zero solutions. Now to find the x-intercept, I'm going to let y equal to 0. We have 2. 3x plus 1, x minus 5. Now we know that these ones are multiplying, the 2 is multiplying, the 3x plus 1 is multiplying, and the x minus 5 is multiplying. And we know it has to be equal to 0. So for example, if I have 7 times a number is equal to 0, what must that number be? It must be a 0. Do you guys agree? If we have 0, a number times 7 is equal to 0, we know that that number must be 0 in order for it to be equal to 0. If we have two numbers multiplied together and it's equal to 0, we know that either one number is 0, the other number is 0, or both must be 0. So we're going to take the same thought, because we know that those three numbers, 2, x plus 3x plus 1, or x minus 5, are equal to 0 when they multiply together. We know that one of them or all of them must be equal to 0. So we're going to place each one equal to 0. 2 equal to 0, 3x plus 1 equal to 0, and x minus 5 equal to 0. Now we know that that's not possible. 0 is not equal to 2. Now we're going to solve for x, so I'm going to move that 1 to the right, becomes a negative, so 3x is equal to negative 1. I'm going to divide by 3, so x is equal to negative 1 over 3. I'm going to move the 5 to the right, becomes a positive. And we have two solutions. X is equal to negative 1/3, or x is equal to 5. Either one will make this equal to 0, will make this statement true. Now, those are called the roots, the x-intercepts, the solutions. The x-intercepts, that means that the graph is going to cross at 5 on the x-axis and negative 1/3. And this parabola will be facing up because that first number, the x squared, is positive. And at this point, it doesn't matter how deep you go on your shape of the parabola, because in order to be able to find the depth or the lowest point, we'll have to find the vertex. But we're not going to focus on the vertex right now. Let's go to example number 1. It says solve the quadratic equation by factoring, then sketch the graphs using its roots. First, we're finding the roots, which is the same thing as x-intercept. So I'm going to let, instead of the y, I'm going to replace it with a 0 to find the x-intercept. I'm going to go and factor this out. Factors of x squared will be x and x. Factors of 10 will be 5 and 2. I'm going to make the 5 a negative, that's a positive. And let me double check. X times x will give me x squared. That gives me 2x. This will give me negative 5x. And that gives me negative 3. And then negative 5 times 2 will give me negative 10. Then I'm going to use my zero product property. Just on those two. We have x minus 5 is equal to 0 or x plus 2 equal to 0. I'm going to go and add 5 on both sides. X is equal to 5. Minus 2 on both sides. X is equal to negative 2. I'm going to go and plot the points on the x-axis. Those are my roots, which are also called x-intercepts. And negative 2. X squared is positive, so that means that it will be facing up. It doesn't matter how low you go. At this point, we'll explore more the properties of parabolas and functions on the next chapter. At this point, you can just make a sketch. Example number 2. I need to be able to solve the following quadratic equation by factoring, and then I'm going to sketch the graph. First, to find the roots or the x-intercepts, I'm going to let y equal to 0. Now, many of you guys are just tempted to do the double parenthesis to factor. You want to be able to take a pause and say, is there a number that divides 2, 2, and 24? Yes, 2. Now, since the first number is negative, the x squared is negative, you want to factor out a negative 2. What do I need to multiply negative 2 to get negative 2x squared? X squared. What do I need to multiply negative 2 times what will give me positive 2x? Minus 1x. What do I need to multiply negative 2 to get positive 24? Negative 12. Now, I'll need to continue to factor this out. 0 is equal to negative 2, double parenthesis. Factors of x squared will be x and x. Factors of negative 12 will be 6 and 2, 12 and 1, or 3 and 4. So I'm going to use 3 and 4. The 4 will have to be negative, this will have to be positive. And I'm going to double check. X times x will be x squared. X times negative 4 will give me negative 4x. 3 times x will give me positive 3x. Does that give me negative 1x? Yes. And positive 3 times negative 4 will give me negative 12. Now from here I'm going to use my zero product property or my t-chart. And let me do one more. So 0 is equal to negative 2? False. Now many of you guys are saying, no, do I really need to place this equal to 0? No, if this does not have an x, then you don't have to do this. But I'll be doing this just to make sure that you guys understand that this is not possible. So 0 is not equal to negative 2, so that gives me nothing. From here, x plus 3 equal to 0, and x minus 4 equal to 0. I'm going to move my 3 to the right, becomes a negative. I'm going to move my 4 to the right, becomes a positive. So my y-intercept, one of them is 4, 2, 4. The other one is negative 3. Remember, those are called y-intercepts, roots, zeros, solutions. Now the first number, the x squared, is negative, so that means that my parabola will be facing down. Oops, missed the first one. Assume that I place them two. So you have to cross both. And it doesn't have to be perfect, as you guys can tell. But you kind of get an idea that this represents the x-intercepts, the roots, the solutions,